So same setup. I have x squared minus 4, and then I have x squared plus 3 to the 1/2 power, minus x squared minus 4 squared, and then x squared plus 3 to the 3/2 power. So what do I have in each here and here? What can I take out of each part? Now, the parentheses is like its own thing.
X squared plus 3.
What else?
X squared minus 4, but on the second square.
So an x squared minus 4, and so I have one of those, and I have two of those, right? So what's the most that I can take out? I can only take the most that I can take out is the least amount that I have. So what's the least amount of x squared minus 4s do I have? 1. Okay. Do the same thing now with the x squared plus 3s. What's the most that I have, or what's the least amount that I have of the two? 1/2. So x squared plus 3 to the 1/2 power. So now, if we look at it this way, I took everything out of that one, right? Yeah. I took out an x squared minus 4. I took out an x squared plus 3 to the 1/2 power. So all I'm going to have there is just going to be a 1. Minus, okay, all I did was just bring the sign with me. I had in the second part of the piece after the minus sign, I had an x squared minus 4 squared. I took one of those away, so what am I left with? Aren't I just left with just one of those?
Yep.
Same way. The biggest thing here is try not to think about it as like all of x squared minus 4 and x squared plus 3. Just think about it, since it's in the parentheses, think about it as one term. Like, what would you do, essentially, if you had, like if we had m and then n to the 1/2 minus m squared times n to the 3/2 power. Okay? It's the same idea, just it's got a lot of extra stuff with it, right? You would still do the same thing. Like, you would still just take out one m, right? You would still, like, all you would do here was you would take out an m out of each one. You would take out an n to the 1/2, and you'd have 1 minus, right? It's the same idea, it's just you've got, your base is just a little more elaborate than what it is if it was just a regular single term. Okay? So if you can really look at it like this instead of everything else and kind of simplify it there, you're going to do the same thing. It's just there's more terms, there's more kind of pieces and parts to the actual original equation. Because, like, what would you do? Like, what would you do on the one that's like in the yellow box? You would just go m to the first, right? And then what do you have to do? What plus 1/2 gives you 3/2? 1. 2/2 are just 1, so it'd just be n to the first power, right? Like, that would be how you would factor it. Right? So don't let all the other stuff that's going on. So, like, what's the only thing that I have to add down here in red? I have the x squared. Like, if you think about x squared minus 4 is the m, and the x plus 3, or x squared plus 3 is the n, what's the other part that I have to add right here?
1.
No, not 1.
Well, x squared.
Yeah, x squared plus 3 to the first power. Okay? Now, I can factor this, okay, because it's a difference of two squares. So if I'm going to completely factor this thing, it's going to be x minus 2, x plus 2, and then x squared plus 3 to the 1/2 power, and then I could write it out x squared plus 3 to the first. Like this here is completely factored